grade 11s, welcome to the show that is proudly sponsored by Macmillan. Thank you so much for tuning in. We are here doing mathematics with Natasha. How are you?
Hello girls, how
Hi.
are you doing?
Great, thanks. How are you, Natasha?
Very, very good to see both of you.
I know.
And nice to see that we've got a new vibrant presenter
We
in
have.
the
Please
studio.
introduce yourself,
I'm
actually.
Taboho from Pretoria.
Nice to meet you.
And introduce yourself to the mindset as well.
Yes. I'm Taboho Precious, studying my BCom Internal Auditing at Tuks University and aspire to be your next Mindset Learn presenter.
Awesome. And I'm Katleho, as you guys know. Today
Yes.
we're doing grade 11 on Learn Extra Live. Aren't you excited, grade 11s?
It's exciting.
Yeah.
I'm excited for them.
That's
Don't forget to post on Facebook. Take advantage of our live presence. We are here to aid and assist you, right, Kat?
We really are, guys. What's our page again? Say it again.
www.facebook.com/learnextra.
And our Twitter handle is @LearnExtra. So make sure that you jump on this page, guys. Make sure that you use this page to the fullest of your potential. Tebogo, please tell them about our random acts of kindness.
Oh yes, we have a random act of kindness where you can post your random act of kindness. We'd love to read about it. We love all the mindsetters to read about it and take example from you. You win an awesome hamper at a draw at the end of the week, hopefully.
Must I tell them
think.
what's inside
Yes,
it?
please
Okay,
do.
guys, this hamper is from Simba. It's a Cheetos party pack. As you can see, there's this really big Cheetos packet. There's more Cheetos chips. If you don't believe me, there's some here. There is our Cheetos notepad and pen. There's mindset lanyards and mindset pens, and you can win this awesome t-shirt that we're wearing as well. There's also CDs. Tebogo, please show them the CDs. They're really awesome. I want
We
them.
have Love Song CDs, we have Unati, we have Donald, we have Kaya for you, and we have Malik.
Awesome. Thank you, Tebogo.
Well, Natasha, you can take it away.
Okay, thank you guys. Sure, there's so much going on here, so much of excitement. So many reasons for you guys to tune in, and obviously the most obvious one, it's time for grade 11 number patterns. Now, grade 11s, I hope that you were listening when Tamlin was going through grade 10 number patterns, because obviously that's revision for you for this year. So just to let you know what we're going to be doing in this lesson and then in next week, we're going to do number patterns over 2 weeks with you grade 11s. We're going to eventually get to a point where hopefully you all feel comfortable with quadratic sequences. But today we're going to look at revising arithmetic sequences, and we're also going to introduce to you quadratic sequences. Now, just a quick revision, and again, if you were paying attention when Tamlin was going over this with the grade 10s, you would have heard this. But remember, what is a sequence? Hopefully you all know what a sequence is. A sequence is numbers written in a definite order in which each number is related to the previous one by a specific rule. Okay, so the numbers are written in a definite order, and each number is related to the one before it. Remember, previous means one before it, by a rule, and these are called sequences. So if we look at the example 2, 4, 6, 8, something that you guys would be very familiar with, this is the sequence of even numbers. Right? Now remember, for this to be a sequence, each number must be related to the one before it by a specific rule. Now, if you look at the numbers 2, 4, 6, and 8, you can see that in order to go from 2 to 4, we add 2. To get from 4 to 6, once again, we add 2 to 4. And then to get from 6 to 8, we add 2 to 6. Again, if you were paying attention in the grade 10 session, you would have seen that this is called a linear number pattern. So in a linear number pattern, you'll remember from last year that all the terms are related, or the rule that joins a linear number pattern together is that there's a common difference between the terms. Do you remember what a term is? A term, each number in the sequence is called a term. So for example, 2 would be term 1, 4 would be term 2, 6 would be term 3, and so on and so on and so on. Okay, so we use Tn, all right, where the little n represents the number or the position in the sequence, and we call each number in the sequence a term. Remember that another name for term 1 is A. You'll often see us saying A is the first term in the sequence. Last year, as I said before, you learned about linear number patterns, and these were called arithmetic sequences. And you will remember that in this type of number pattern, there's always a constant first difference between any consecutive terms. So guys, if you're looking at the sequence 2, 4, 6, and 8, the constant first difference is 2. Okay, so when you subtract each of the terms, that's the constant difference that you get. The common difference is the difference, as I said, between any term and the term before it. And remember that we denote the common difference with the letter D. And the general term of a linear sequence, again, this is from grade 10, is Tn is equal to A times n plus B. Now, guys, when you use this formula, remember that the A is the same as your common difference in this linear sequence general term formula. Okay, so in this case, don't get confused now between the A is term 1, but now the A is also the common difference. If you're using the formula for your linear sequence of Tn is equal to An plus B, the A represents the common difference between the terms. Once you have the value of A, and we'll go into an example later on, but once you have the value of A, you can find the general term of the sequence by substituting any term in the sequence in that formula. Okay, so hopefully you're all with me and you all remember this from grade 10. Now the best way to obviously get going with this is to show you guys an example, and this example comes from the Clever Keeping Maths Simple. We're looking at the grade 11 learner's book, and this is page 71, exercise 3.1, number 1C. All right, so remember this is just revision of grade 10. Okay, they give us a general term, Tn is equal to 3n plus 2, and they say write down the first 8 terms of the sequence, and then they say write down the first difference. Now the first thing we need to do is to write down the first 8 terms if we hope to find the first difference. Okay, well actually you only need the first 3 terms, but in this case we're going to write down the first 8 terms. Remember, if you're looking for term 1, you simply replace the n with the term position that you're looking for. So if I'm looking for term 1, in place of n, I substitute 1. Okay, so term 1 is going to be 3 times 1 plus 2. So that's going to be 3 plus 2, which is 5. Okay, similarly, if I want term 2, I'm going to substitute 2 in place of n. So it's going to be 3 times 2 plus 2. So that's going to give me 6 plus 2, which is 8. Okay, term 3, we substitute 3 in place of n, and we get 3 times 3 plus 2. So that's going to give me 9. 9 plus 2 is 11. Term 4, and we go on all the way, guys. I'm not going to do all 8. I think you kind of get the picture now, but we do the same thing for term 4. We substitute 4 in place of n, and we get 3 times 4 is 12. 12 plus 2 is 14. Okay, and remember you'll carry on all the way like that till we get to term 8, because they asked us for the first 8 terms. Now, very importantly, in a linear number sequence, when you're dealing with an arithmetic sequence, once you have your first 3 terms, you can work out the common first difference, or the constant first difference. Okay, we only need 3 terms to work out the constant first difference. All you do to work out the difference, once again, you'll remember from last year, is we say D, the common difference, is equal to term 2 minus term 1. And that's also equal to, or you can say term 3 minus term 2. And that's actually a good way for you to check, because term 2 minus term 1 must give you the same answer as term 3 minus term 2. So once again, if we look at our first 4 terms, we've got 5, 8, 11, and 14. Okay, remember I said you only need to work with 3 of those terms. So if I say term 2, which is 8, minus term 1, which is 5, I'm going to get 8 minus 5 gives me 3. And then term 3 minus term 2, so that's 11 minus 8. My answer is also 3. Similarly, if you said 14 minus 11, you'll also get 3. So what that means is that your constant difference or your common difference is 3 in this linear number pattern. And what you'll notice is if you look at the formula quickly, Tn equals 3n plus 2, do you see that that common difference of 3 is actually the value of A? Okay, which is what we're going to get to in a later example. But I think, guys, it's quite a lot to take in, quite a lot of revision to do, so I think it might be a good spot to take a quick break.
Yes.
Awesome,
It is now
Natasha.
time for a quick break. Don't forget to tune in and post all your questions. If you have any concerns, queries, do not hesitate. Ask. Bye.
See you just now, guys.
Welcome back, grade 11s. It's good to have you here. If you just joined us, welcome. I hope you had a little stretch, sharpened those pencils, had a glass of water and freshened up. We're still busy here with mathematics, sequence patterns, and do not forget to post your random acts of kindness. We would love to read more what you guys have been up to and what you've been doing to better the society. Natasha, it's over to you.
All right, thank you so much, Tebogo. Now, guys, as Tebogo said, you guys need to be posting on the page. And obviously, if you have any questions, please feel free to post them on number patterns. Please don't ask me about something else that we're not covering in today's lesson. So only about number patterns, grade 11s. Remember, today we are looking at revising number patterns from grade 10, and then we're also going to do an introduction to quadratic sequences, which we will finish off next week. Okay, let's move on to the next question. So this is question 2. This comes from the Clever Keeping Math Simple grade 11 learner's book. This is page 71, exercise 3.1, and this is number 2E. Okay, so the question reads, determine the next 2 terms of the sequence, and the sequence that they give us is 3, 10, 17, and 24. Now, guys, if you want to determine the next 2 terms in the sequence, we need to figure out if it's linear. At this stage, the only sequence that you've learned about, because we're revising grade 10 work, is linear. Okay, so you've only learned about linear sequences, so this is going to be a linear sequence, but it won't be that easy as we go on. Okay, so we've got 3, 10, 17, and 24. Remember, to check that this is linear, we're going to say, is there a common difference? So term 3 minus term 2 must be equal to term 2 minus term 1, and this will give us our constant first difference, if it is a linear sequence. So let's have a look. This is term 1, term 2, term 3, and term 4. So term 3 minus term 2, 17 minus 10, and 17 minus 10 is 7. Now let's have a look at term 2 minus term 1. So 10 minus 3, and that's also 7. So therefore, we have a constant first difference, which gives me the common difference between the terms of 7. So in other words, this is a linear number pattern. So if I want the next 2 terms of the sequence, all I've got to do is add on my constant first difference. So the next terms, remember this is term 4. Term 5 is going to be 24 plus your constant difference of 7. And 24 plus 7 is 31. And then for term 6, which will be the next term in the sequence, I'm going to say the previous term, which is 31, plus the common difference of 7, and I get 31 plus 7 is 38. What if I asked you to find the 100th term? Now, you can't keep on adding and adding and adding, going from term 6, add the next one, 7, 7, 7, 100 times. That's going to take forever. You'll be on one question through your whole exam. Okay, so we obviously need a neater, quicker way to work out any term in the sequence. In order to do that, that leads us to question 2, where they ask us to write down the general term Tn of the sequence. Remember that Tn, your general term, helps you to find any term in a sequence. Now in this case, in the case of the linear number patterns, our general term is given by Tn equals An plus B, where A is equivalent to the constant first difference. Okay, so A is the same as the constant first difference of the number pattern. Okay, here we've seen that the constant first difference is 7. So therefore in our formula, Tn is going to be equal to 7n plus B. But remember, if you want the general term, you're also going to have to work out B. How do you work out B? We go back to the sequence and we see we've got a whole list of numbers. Now, if you want to work out B, you need to use substitution that you learned in grade 9. Use any term in the sequence and use the value of that term to work out B. So for example, and you can really use any term, I'm going to use term 1. Remember term 1 here was 3. Okay, so I'm using term 1 has a value of 3. So therefore, in order to find B, I need to use substitution and say term 1, so replace n with 1 is equal to 3. But remember, our formula so far says Tn is equal to 7n plus B. So I'm going to say, well, term 1 is actually going to be equal to 7 times 1 plus B. But I also know that term 1 has a value of 3, so I make that equal to 3, and I solve for B. So I'm going to get 7 plus B is equal to 3. Therefore, B will be equal to, take your 7 to the right-hand side and just be careful with your signs. So 3 minus 7 will give me negative 4. Okay, so therefore, our formula now becomes Tn, or our general term, becomes Tn is equal to 7n minus 4. So that's the general term. Remember, the general term will help you to find any term in the sequence. So guys, what I always say to everyone is just check any term in the sequence and see if your formula works. So for example, let's check term 2. So I substitute 2 in place of n. 7 times 2 minus 4. So I get 14 minus 4 is 10. And then let's go back and have a look at the formula. Look at the sequence, and we see term 2 is in fact 10. So therefore, our formula is one that makes sense. It is one that's working with the sequence that we've got. So we have found the correct values for A and for B. Okay, so I'm going to quickly check over with Tebogo and see how she's doing on the Facebook page and how you guys are understanding at home. Tebogo?
Well, I have Pela here who says he's thirsty for maths today. So far, we don't have any questions, but I trust that the mindsetters are on track with you and they do completely understand about the lesson today. Yeah, we don't have any questions to know.
Okay, so guys, you're obviously understanding so far because all we've done is revision. So everyone's obviously quite confident with their grade 10 work, which is fantastic to see. And now we're going to move on to quadratic sequences, which is the section that you guys in grade 11 will now be doing for the rest of your number pattern section in grade 11. So the general term for a quadratic sequence is Tn is equal to an squared plus bn plus c. That's the general term. Now remember, whenever you deal with sequences, you're going to have a general term. In the last one we had Tn equals an plus b, and that was the general term for linear sequences. Now we're looking at Tn equals an squared plus bn plus c, and that would be the general term we use for quadratic sequences. Okay. Also, how you can identify that it's quadratic, if you look at the highest power of n, it's a square. And whenever you have the highest power in a general term being a square, you will be dealing with a quadratic sequence. But remember, and we will do this in next lesson, in order to find the general term, you'll need to find a, b, and c. But guys, that's something we will touch on next week. For now, I want to lead into quadratic sequences by looking at an example. Okay. We are asked to write down the first 4 terms of the sequence, and they give us the sequence. Okay, remember to work out the first 4 terms. If you're given the general term, you substitute the term number that you're looking for. So if I want term 1, I substitute 1 in place of n. So we get 1 squared plus 1 minus 3. Obviously, I'm using Tn equals n squared plus n minus 3. And I'm going to get 1 plus 1 is 2 minus 3 is negative 1. Okay, term 2. Again, this method stays the same. If you want to find any term in the sequence and you have the general term, you simply substitute the position of the term. Alright, so we've got 2 squared is 4, 4 plus 2 is 6, 6 minus 3 is 3. And we need term 3, so once again we substitute 3 in place of n. We get 3 squared plus 3 minus 3. So obviously the 3 and the minus 3 are going to cancel, and I'm just left with 3 squared, which is 9. Term 4, we substitute 4 in place of n, and we get 4 squared plus 4 minus 3. 4 minus 3 will give you 1. 4 squared is 16. 16 plus 1 is 17. So let's just write down the sequence that we have from substituting these terms in. We got term 1 is minus 1. Term 2, we got a value of 3. Term 3 was 9. And term 4 was 17. Okay, remember when I put dots like that, it means the sequence continues. Now guys, if you just look at these numbers and you try to subtract and find a first difference, you'll see that it's not constant. So let's do it. If I say term 2 minus term 1. So I'm going to say 3 minus minus 1. And here I'm going to do it in brackets because I know a lot of people make careless mistakes and then they get the first differences and second differences wrong. 3 minus minus 1, that's going to become 3 plus 1, which is 4. Okay. Then, so the difference between those two is 4. Now let's have a look at term 3 minus term 2. So it's 9 minus 3, which is 6. And we see that the difference between 9 and 3 is 6. So already you can see, hey, hang on, these are not constant. So obviously this cannot be a linear sequence. 17, which is term 4, minus term 3, which is 9. 17 minus 9 is 8. Okay, 8 plus 9 is 17. So therefore, the difference between term 4 and term 3 is 8. So if you have a look at these numbers, you'll see constant first difference? No, doesn't work. There's no constant first difference. So we've worked out the first difference and we've seen that it's not constant. Then they say work out the second difference. Okay? Working out the second difference is the difference between the first differences. Okay, so we found the first differences. Okay, that's your first difference. Now, to work out the second difference, it's actually the difference between each of the terms in the first difference. So, we say 6 minus 4. 6 minus 4 is 2. 8 minus 6 is also 2. All right? So, therefore, what you see is we have a constant second difference, and this leads us to the definition of a quadratic sequence. In a quadratic sequence, there will always be a constant second difference between your terms in the sequence. That's how you know that you were dealing with a quadratic sequence. So there's got to be a constant second difference in order for you to say, okay, this is quadratic, as we did in this case. Okay, I think it might be time to take a break, but I'm going to check
Yes,
with
it
Teboho.
is. Mindsetters, it is time for a quick ad break. You've earned yourselves the right to refresh. We'll see you in a few minutes. Do not go away and don't forget to post. See you. Welcome back, grade 11s. Thank you so much for joining us. We are here with the grade 11 math show that is proudly sponsored by Macmillan. Do not forget to post your random act of kindness, and you may stand a chance to win yourselves an awesome packet of Cheetos, this wonderful hamper, this beautiful t-shirt that I'm wearing, and I've got a notepad, a pen, and lanyard that is awesome to win. I'm glad you guys will enjoy it. And another thing that is up for grabs are these awesome CDs that come from Universal. You can win yourself Malik, you can win yourself Kaya, you can win yourself Donald, you can win yourself Unati, and love songs. So today we're busy with grade 11 sequence patterns. Do not forget to post your questions, your concerns, anything you need to be clarified, and I'm going to hand it over to Natasha now.
Okay, guys, so we had a look during the break, and Teboho, there was a question on that page that one of the learners needed a bit of help with. So
Yes.
what would they like to know?
Keith would like to know, how is your formula different from the Tn equals a plus n, bracket n minus 1, close bracket d?
All right, so his name is Keith.
Keith.
All right, if you look at that formula, grade 11s, Tn equals a plus n minus 1 times d. That is another way to find the general term for a linear number pattern. Okay, that is another way that you can do it. So far we're using this. Tn equals a n plus b. This a and this a are not the same. In grade 10, you only learned, or you only should have learned, I know that some teachers were naughty and they taught this one already, but in grade 10 you only should have learned Tn equals an plus b. Okay, that's the way you learn to find the general term in a linear number pattern. Tn equals an plus b. The other formula, Tn equals a plus n minus 1 times d, that is a grade 12 formula. So yes, it will still give you the same answer, but technically, if we're going according to the new caps, okay, it is not correct technically for you to have been taught that in grade 10. If you were taught that, it's not a train smash, absolutely nothing wrong with the formula. It's just in terms of the syllabus, you were only supposed to learn that grade 12 formula, obviously in grade 12. So the bottom one, Tn equals An plus B, is the one you should have used for grade 10. But if you use this one, nothing wrong. It's just technically not in the syllabus in grade 10. Okay, Tebogo, so have we answered Keith's question there?
Yes, I trust that we have. I hope that he understands. Leonard would also like to know if there's a possibility for the third order in sequence.
The third order. Okay, I'm not sure what he means by the third order.
Okay.
I think he's talking about the powers,
Yeah,
because in the old days they used to call powers orders, which is silly for them to still be doing now. But anyway, if you mean that the power of the n is a cube, no. Absolutely not. Remember, in grade 11, you're learning about quadratic sequences. Quadratic, think about quadratic equations, the parabola. All of those are quadratic related, and the highest power in a quadratic expression is 2. Okay, so we will not be dealing with n cubes when we're looking at quadratic sequences. Grade 11s, in grade 11, your main focus in number patterns, you do a bit of revision of linear patterns, and it's quadratic sequences. That's what you're learning. Quadratic sequence, not n cubes. All right, Tebogo, are we all happy there?
Yes, I think we're all set now. They have their questions answered. Mindsetters, we're still waiting for your questions. We'd love to help you, aid, and assist you. Back to you.
Okay guys, so let's get on with our lesson on quadratic sequences. Remember, I showed you before the break that if you would like to tell if a sequence is quadratic, there has to be a constant second difference when you are given the sequence of numbers. Okay, we're going to look at another example. This comes from, again, the Clever Keeping Maths Simple. This is grade 11, Learner's Book, page 71, exercise 3.2, number 2. Okay, we are asked to write down the first 8 terms of the following sequence, and then we have to calculate the first and second difference. Okay, so the first 8 terms, let's have a look at that first. We've got Tn equals 3n squared plus 2. So if I want term 1, just as before, I'm going to substitute 1 in place of n. Remember here, because we're dealing with an n squared, straight away we know that this is quadratic. Okay, so this is a quadratic sequence. We've got 3 times 1 squared plus 2. All right, and that's going to give me 3 plus 2, which is 5. All right, for term 2, we substitute 2 in place of n. And we're going to get 3 times 2 squared plus 2. So that's going to give me 4 times 3 is 12. 12 plus 2, 14. Term 3, we replace n with 3, and we get 3 times 3 squared plus 2. So 3 squared is 9. 9 times 3, 27. 27 plus 2, 29. Okay, and guys, I hope that you at home are awake and you're checking my working out, because obviously I'm just doing it all in my head, and it's quite possible for me to have a little brain malfunction sometimes when I'm doing calculations without double checking them. Okay, 4 squared, 16. 16 times 3, 48, plus 2 is 50. And there's absolutely nothing wrong if you want to, and in fact maybe I should check some of these. There's absolutely nothing wrong with checking your answers if you're not feeling confident in them. So let's check term 3. We've got 3 times 9 plus 2. 29, yes, we are correct. And then 3 times 16 plus 2 is 50. Okay, so as I say, absolutely nothing wrong with just double checking. Then term 5 is going to be 3 times 5 squared plus 2. And this is going to give me 5 squared is 25. Once again, let's just check. It's going to be 25 times 3 plus 2. And that's going to give me 77. Okay, guys, you will continue in this way all the way to the 8th term. Okay, I'm not going to do all of them because I think you sort of get the idea so far. So our first 5 terms, we've got 5, 14, 29, 50, and 77. Obviously, the question asked you to go on for 8 terms, so you would continue substituting values for n all the way to 8. Okay, then we had to work out the first and second difference. So remember, and I'm just going to do this in a different color, to work out the first difference, I just say term 2 minus term 1, term 3 minus term 2, term 4 minus term 3, and so on. Okay, 14 minus 5 is going to give me 9. So that's the difference between those two. Okay, then 29 minus 14, and let's see if my mental maths is right. 9 minus 4 is 5, 2 minus 1 is 1, so that's 15. Difference between 50 and 29, so we've got 10 minus 9 is 1, and 4 minus 2 is going to give me 2. So that's going to be 21. All right, and then obviously you can do the same with that. Once you've got 3 terms in your first difference, remember this is your first difference. Once you've got those 3 terms, in order to check and see what our second difference is and to check if it's common, we only need those 3. So I can straight away subtract these. Okay, so now we're working out the second difference. So we say 15 minus 9, and we get 6. And then 21 minus 15 is also 6. Okay, so we're happy because we've confirmed that yes, it is a quadratic sequence. Obviously it was a quadratic because they gave us the formula as 3n squared plus 2. But we've also confirmed it by showing that there's a constant second difference. And when there is a constant second difference, then your sequence is quadratic. Okay, all right, I think we're going to take a quick break, Tebogo.
Yes, we are. Mindsetters, do not forget to post more of your questions on Facebook. I'm here, I'm reading some of your lovely posts. Makata says she's truly loving this chapter, and she really, because she previously didn't understand, and she's glad that we're having it. And Tori also says it's a wonderful show, she's enjoying it. Don't forget to post your random acts of kindness. We'd love to read more of what good you've been up to. And, well, see you after the break. Welcome back, grade 11s. Thank you so much for tuning in. I trust and hope that it will be worth your while. Please post all your questions. We're waiting to aid and assist you. We will be here to answer all your questions. We appreciate for you tuning in. Also do not forget to post your random acts of kindness. There's an awesome prize here that is up for grabs that you can win for yourself, and I'm sure you will enjoy it because I see beautiful things here. You get awesome CDs from Universal. You get this beautiful bag, some Cheetos snacks, the t-shirt that I'm wearing, a beautiful pen, and a lanyard. So post your questions. I'm waiting to read all your beautiful remarks and what good you've been up to. And I'm glad that you tuned in. Natasha, I'm going to hand it back to you.
Okay, guys, and hopefully you all agree that Tebogo is doing really well, manning the whole social media by herself. Well done, Tebogo.
Thank you.
And now, Tebogo, I did see a question on the page where someone had given us a list of sequences, and they said, how do you find the general term? I'm not sure if it's still on the page.
Yes, let me quickly get to it, and I'll find it quickly. Or how about I'll just read it out when it's here.
Okay. Well, guys, I had a look at the question, and it was saying something like, one of you, I can't remember the name now, but she gave us a list of numbers in the sequence like 2, 5, 7, 12, and you said, how do we find the general term? Now, that we will be discussing in the next session next week, because obviously today we can only do so much, and we're not going to be able to fit in finding the general term of a quadratic sequence. That we're going to look at next week. So if you really want to know how to do that, please tune in next week, Monday, for the continuation of quadratic sequences. Okay? But what we want to do today is cement everything you've learned on quadratic sequences. So remember what I've told you. You can identify a quadratic sequence by the highest power. If they give you the general term, the highest power has to be a 2. Okay, that's the one way. And then the other way you identify a quadratic sequence is there has to be a constant second difference between the terms. So if there's a constant second difference in your sequence of terms, then it is a quadratic sequence. Okay, and we're going to do one last example to sort of just cement and put everything together for you. Okay, so here we've got a sequence Tn equals n squared plus 3, and we are asked to find the first 4 terms and then also the first and second differences. So we've given the formula, or the general term, is n squared plus 3. So therefore, because the power here is 2, that tells us it's quadratic. But obviously, if we want to confirm that, there should be a constant second difference. Okay, so constant second difference confirms to us that this is in fact a quadratic sequence, although here it is obvious because we are given the general term. Okay, let's find the first 4 terms, and you guys should be really good at this now. To find term 1, I substitute 1 in place of n, and I'm going to get 1 squared plus 3, which is 1 plus 3, 4. To find term 2, I put 2 in place of n. And we get 2 squared plus 3. So that's going to be 4 plus 3, which is 7. And term 3, we put 3 in place of n. So we get 3 squared plus 3. So that's 9 plus 3, which is 12. And then lastly, we want term 4, so we put 4 in place of n, and we get 4 squared plus 3. So that's going to be 16 plus 3, which is 19. Okay, so we have the first 4 terms. We've got 4, 7, 12, and 19. Those are the first 4 terms of the sequence. The question then said, find the first difference. Now remember, to find the first difference, it's term 2 minus term 1, term 3 minus term 2, and term 4 minus term 3. That will give me the first difference. So 7 minus 4 is 3. And guys, obviously be careful with your signs. If you know that you make careless sign mistakes, then do it on your calculator. 12 minus 7 is 5, and then 19 minus 12 is 7. Okay, so this line, that is our first difference. As you can see, it's not constant. If it was constant, we would be dealing with a linear number pattern. Okay, not constant. First difference, not constant. We're going to find the second difference by taking the differences between the terms in the first difference. So 5 minus 3, so this is now a second difference. 5 minus 3 will give us 2, and then 7 minus 5 is 2. So as you can see, we have a constant second difference of 2, which means that this does confirm, yes, in fact, we were dealing with a quadratic sequence. Okay, so once again, just to round up, what have we said? If you have a constant second difference, it means that your sequence is quadratic. Or if the highest power in your general term is a 2, then your sequence is also quadratic. All of you that are asking about how to find n, how to find the general term, for that you're going to have to tune in again next week, Monday, when we'll look at the second part of number patterns. I'm going to go over to Tebogo to see if anyone has any final questions for today's show.
Yes, Sharon would like to know, what if we were given a sequence and asked to represent it on a graph? How can we represent it on a graph?
Well, guys, remember that all maths is so fantastic because everything is linked. Now, if you had, remember last year you did linear number patterns, and there the highest power was 1. So let me quickly touch on that. And we'll just look at the linear number patterns first. So remember last year you did Tn is equal to An plus B. And that was a linear number pattern, and the highest power here was 1. Now, if you were asked to graph this, okay, it follows a linear pattern. So remember from straight lines, how does your straight lines look? Obviously, we don't know what the formula is, but your terms are going to be points that you can plot on a straight line, so that if you join them all up, because it's a linear number pattern, it will follow the pattern of a straight line. It makes sense. If it's a linear number pattern, it's going to look like a linear graph. Another word for a linear graph, straight line. Okay, now when we deal with quadratic number patterns, okay, so the formula here is Tn equals An squared plus Bn plus C. This 2 tells us it's quadratic. And you guys, some of you will remember from last year you did parabolas, okay? So, if we were to graph the terms of whatever sequence we have, depending, I mean it can change, but you were going to get points that when you plot them, and if you try to pass a graph through those points, it will end up forming a parabola where the highest power is also 2. So a nice question. If you graph a quadratic sequence, it's going to look like a quadratic graph. Another name for a quadratic graph, a parabola. If you graph a linear sequence, it's going to look like a linear graph. Another name for a linear graph, straight lines. A nice question. Let's see if there's anything else like that on the page.
No, we don't have any questions. Oh, yes, I have one here. Marunga would like to know is there a sequence with an x? Like, can she have a sequence with an x?
As the x is your variable. Remember, guys, the n just represents a variable, so you could have an x. It's not really something we use, though, for terms. When we're talking about terms, we prefer to stick with n, so generally no. Okay, but I think that's about it, guys, and if you would like to know anything more about sequences, grade 11s, tune in next Monday. Teboho, over to you.
Thank you so much, grade 11s, for tuning in. I really trust and believe that it was worth your while. I'm glad you understand and you are really glad for the show. Thank you to Macmillan for sponsoring us. We really appreciate it, and thank you for your wonderful support. I love it. I appreciate it. And thanks for tuning in. We had an awesome show, and I'm glad you enjoyed it. Next show would be the grade 12s. Don't forget to tune in.